A star is an astronomical object comprising a luminous spheroid of plasma held together by self-gravity. The nearest star to Earth is the Sun. Many other stars are visible to the naked eye at night. Their immense distances from Earth make them appear as fixed points of light. The most prominent stars have been categorized into constellations and asterisms, and many of the brightest stars have proper names. Astronomers have assembled star catalogues that identify the known stars and provide standardized stellar designations. The observable universe contains an estimated 1022 to 1024 stars. Only about 4,000 of these stars are visible to the naked eye, all within the Milky Way galaxy. A star's life begins with the gravitational collapse of a gaseous nebula of material largely comprising hydrogen, helium, and trace heavier elements. Its total mass mainly determines its evolution and eventual fate. A star shines for most of its active life due to the thermonuclear fusion of hydrogen into helium in its core. This process releases energy that traverses the star's interior and radiates into outer space. At the end of a star's lifetime, its core becomes a stellar remnant, a white dwarf, a neutron star, or, if it is sufficiently massive, a black hole. Stellar nucleosynthesis in stars or their remnants creates almost all naturally occurring chemical elements heavier than lithium. Stellar mass loss or supernova explosions return chemically enriched material to the interstellar medium. These elements are then recycled into new stars. Astronomers can determine stellar properties, including mass, age, metallicity, chemical composition, variability, distance, and motion through space by carrying out observations of a star's apparent brightness, spectrum, and changes in its position in the sky over time. Stars can form orbital systems with other astronomical objects, as in planetary systems and star systems with two or more stars. When two such stars orbit closely, their gravitational interaction can significantly impact their evolution. Stars can form part of a much larger gravitationally bound structure, such as a star cluster or a galaxy. The word star ultimately derives from the Proto-Indo-European root H2-ster, also meaning star, but further analyzable as H2H1s. To burn, also the source of the word ash, plus ter, agentive suffix. Compare Latin stellar, Greek aster, German stern. Some scholars believe the word is a borrowing from Akkadian istar, Venus. However, some doubt that suggestion. Star is cognate, shares the same root with the following words: asterisk, asteroid, astral, constellation, Esther. Modern version of the stellar classification scheme was developed by Annie J. Cannon during the early 1900s. 30. The first direct measurement of the distance to a star, 61 Cygni at 11.4 light-years, was made in 1838 by Friedrich Bessel using the parallax technique. Parallax measurements demonstrated the vast separation of the stars in the heavens. Observation of double stars gained increasing importance during the 19th century. In 1834, Friedrich Bessel observed changes in the proper motion of the star Sirius and inferred a hidden companion. Edward Pickering discovered the first spectroscopic binary in 1899 when he observed the periodic splitting of the spectral lines of the star Mizar in a 104-day period. Detailed observations of many binary star systems were collected by astronomers such as Friedrich Georg Wilhelm von Struve and S.W. Burnham, allowing the masses of stars to be determined from computation of orbital elements. The first solution to the problem of deriving an orbit of binary stars from telescope observations was made by Felix Savary in 1827. The 20th century saw increasingly rapid advances in the scientific study of stars. The photograph became a valuable astronomical tool. Carl Schwarzschild discovered that the color of a star, and hence its temperature, could be determined by comparing the visual magnitude against the photographic magnitude. The development of the photoelectric photometer allowed precise measurements of magnitude at multiple wavelength intervals. In 1921, Albert A. Michelson made the first measurements of a stellar diameter using an interferometer on the Hooker telescope at Mount Wilson Observatory. Important theoretical work on the physical structure of stars occurred during the first decades of the 20th century. In 1913, the Hertzsprung-Russell diagram was developed, propelling the astrophysical study of stars. Successful models were developed to explain the interiors of stars and stellar evolution. Cecilia Payne-Gaposchkin first proposed that stars were made primarily of hydrogen and helium in her 1925 PhD thesis. The spectra of stars were further understood through advances in quantum physics. This allowed the chemical composition of the stellar atmosphere to be determined. With the exception of rare events such as supernovae and supernova imposters, individual stars have primarily been observed in the local group and especially in the visible part of the Milky Way, as demonstrated by the detailed star catalogues available for the Milky Way galaxy and its satellites. Individual stars such as Cepheid variables have been observed in the M8737 and M100 galaxies of the Virgo cluster, as well as luminous stars in some other relatively nearby galaxies. With the aid of gravitational lensing, a single star named Icarus has been observed at 9 billion light-years away. The concept of a constellation was known to exist during the Babylonian period. Ancient skywatchers imagined that prominent arrangements of stars formed patterns, and they associated these with particular aspects of nature or their myths. 12 of these formations lay along the band of the ecliptic, and these became the basis of astrology. Many of the more prominent individual stars were given names, particularly with Arabic or Latin designations. As well as certain constellations and the Sun itself, individual stars have their own myths. To the ancient Greeks, some stars, known as planets, Greek planetes, meaning wanderer, represented various important deities, from which the names of the planets Mercury, Venus, Mars, Jupiter, and Saturn were taken. Uranus and Neptune were Greek and Roman gods, but neither planet was known in antiquity because of their low brightness. Their names were assigned by later astronomers. Circa 1600, the names of the constellations were used to name the stars in the corresponding regions of the sky. The German astronomer Johann Bayer created a series of star maps and applied Greek letters as designations to the stars in each constellation. Later, a numbering system based on the star's right ascension was invented and added to John Flamsteed's star catalogue in his book Historia Coelestis Britannica, the 1712 edition, whereby this numbering system came to be called Flamsteed designation or Flamsteed numbering. The internationally recognized authority for naming celestial bodies is the International Astronomical Union, IAU. The International Astronomical Union maintains the Working Group on Star Names, WGSN, which catalogues and standardizes proper names for stars. A number of private companies sell names of stars which are not recognized by the IAU, professional astronomers, or the amateur astronomy community. The British Library calls this an unregulated commercial enterprise, and the New York City Department of Consumer and Worker Protection issued a violation against one such star naming company for engaging in a deceptive trade practice.